In this video, we're going to look at another difficult question in circle geometry, and it's got a lot to offer us. So buckle up for this one. I hope that you find it useful. And just two disclaimers. The one is that I'm not going to be writing down all the reasons, but in exam you would write the reasons. I'm just going to discuss them with you. And secondly, the way that I approach Euclidean geometry is I fill in as much information as I can as I read it, sentence by sentence, so that by the time I come to the questions, it's a lot more visually appealing and understandable for me. So watch how I do it just to get into my brain. In the diagram, O is the center of the circle, so immediately I'm going to fill in my radii. I'm also noticing that there's a common chord, but I'll touch on that in a sec. They tell us that QRS is Y, and so just from that my mind is kind of thinking, is there angle in same segment? So if I go from R with my fingers, I end up at QS, and if I bounce from that chord, I end up at the circumference here, and that would be Y, angles in same segment. So that's buzzing through my mind. And then the angle at the center would be double the angle at the circumference, and you can use that rule because you've got equal chords. And so imagine if it's the same chord, imagine if I had some extra chords going there, and that would also be Y, then the angle at the center is double Y. I don't think I'm going to fill this all in yet because it can get a little bit busy, but if this is 2Y, then I know that these angles in the corners would both be 90 minus Y because of isosceles triangle, because of the radii. The other thing that's jumping out for me before I go on with reading the next sentence is because these two chords are equal and I've worked out this Y from angles in same segment, I'm going to fill this in as Y as well because I have an isosceles triangle. Again, I could work out this whole angle at the top of this triangle being 180 minus 2Y, but it's never fun when you've got angles that cross over multiple angles. So let's leave that to marinate for a sec. The other thing that's jumping out for me is if this is Y and Y, then the exterior angle here would be 2Y. So that's hopefully helpful. Let's move on with just reading. The tangent at P, so there's a tangent at P, is PT. And so I'm going to pause there for a sec again. A radius is perpendicular to a tangent. So this whole angle is going to be 90. I'm going to just keep that in the back of my mind. The other thing that jumps out is if I've got a circle and I've got a tangent and I've got this thin sliver of a triangle here, then if I've got the angle here as Y, then the angle opposite outside will also be Y. So P3 would also be Y. Reason, tan chord theorem. Great advice is to redraw in seconds little pictures all over your question paper just to help you look more clearly at specific triangles or circles or shapes to help you answer things. And so give a reason why P2 equals Y. So we got that one already and discussed it. Prove that PQ bisects TPS. We've also discussed that. Determine POQ in terms of Y. POQ in terms of Y, that was the angle at the center, is double angle at circumference, but it was a unique case because of having equal chords. And so visually I tried to show you how if you shifted this around, you would have had the Y there, and this is the angle that's double. Prove that PT, this is such a stunner, prove that PT is a tangent to the circle passing through POA. Now this is great to redraw. So you've got a POA that looks pretty much like this. At the moment I've got a 2Y at the top of it, and they're wanting you to prove that PT is a tangent. And so you can't say, no, it's not a tangent because this isn't a circle here. You're just trying to prove that it's got the qualities of a tangent, which would mean that if this angle's 2y, then the exterior angle here should have been 2y. And so we look and see, is TPA here, is that 2y? Yes, we've already proved it. So you just say PT is, it's only for 2 marks, PT is a tangent to this circle. Reason, converse, tan chord theorem. You just say converse whenever the shape wasn't actually a tangent or wasn't actually a cyclic quad, but you just use the reasons of it to prove it. You say the word converse first. And so lastly, prove that OAP, so this angle here, prove that it's 90. Well, we started discussing earlier that because this is perpendicular and we filled it in and we've got 2y's so far, then this angle must be 90 minus 2y. Your reason could just be adjacent angles. And then A would be 90. What's the reason for that? It would just be sum of triangle. I hope that you found that video helpful. If you did, please like it, subscribe to our channel, and share this with your friends. Thank you so much.